Okay guys, so we're in our last section in chapter 5, how exciting. And this whole chapter we've been talking about lines, so we're going to end with section 5.4 comparing linear and nonlinear functions. So obviously lines and functions that are not lines. So obviously we've been talking about mostly linear functions. In Algebra 1 we are going to expand on that and move away from linear functions at some point. So let's just start to talk about linear functions. They show a constant rate of change. I mean, that's the whole point of a line. And think about slope. It rises the same and runs the same every single time. There's a constant slope, okay? A constant rate of change. Rate of change is another word for slope. It doesn't like go like this would be the same slope, and then like this would be a different slope, right? It doesn't do that. That's not a line. A line has the same rate of change, the same slope the entire time. We can determine if a function is linear, is a line, by looking at a graph, an equation, and a table. So it doesn't have to be a graph. Obviously, graph is the easiest, right? Like right away you can tell that's not a line, Miss Prosser, right? Table and equation, we can also do the same. So let's first look at a graph. The graph of a linear function should be represented by a line, right? Hopefully, guys, this is like duh, right? So when we look at problem 1 here, determine which of the following are linear functions. Well, I've got option A, option B, and option C. Hopefully, we can all realize that B is the only linear function. This is actually a cubic function when it goes like that, so it's nonlinear. And this one, we should be a little bit familiar with this one, and I can actually write this as an x cubic function. This is an absolute value function, nonlinear. Guys, they're not lines. That's all we kind of have to be responsible for right now. For it to be a linear function, it has to be a line. What about when we look at a table? Okay, so it's a little bit different. When looking at a table, again, we're talking about this constant change. There must be a constant change in the y value and a constant change in the x value. Okay, and how we do that is we jump from one x value to the next. What's my constant change here? To go from 0 to 7, I add 7. Now, this rule must happen when I continue to jump. 7 to 14, phew, add 7. 14 to 21, add 7. So far, we're good. 25 to 20, subtract 5. 20 to 15, subtract 5. 15 to 10, subtract 5. We've got a linear function. Let's check out B. 2 to 4, I add 2. 4 to 6, I add 2. 6 to 8, I add 2. Okay, looking good. 8 to 4, I subtract 4. 4 to 0, I subtract 4. 0 to negative 4, I subtract 4. Linear function. Okay, 1 to 3, plus 2. 3 to 5, I also plus 2. 5 to 7 plus 2. You think you're good, right? I mean, we still have to check our y values. 2 to 11, I add 9. 11 to 33, I add 22. Right away, I know this is a non-linear function. It's a constant. That constant isn't there, right? There must be a constant change. 7 is our constant change with the x's, minus 5 is our constant change with the y's. Constant change of our x's is 2. There isn't a constant change here. Look, from 33 to 55 to 88, it's 55. Okay? So when we look at a table, we're looking at a constant change. You have to check both the y's and the x's. And now let's just look at an equation. All linear functions have the variable raised to the power of 1. Okay? Any exponents or any variables you see, I mean, just think, oh, it's not letting me write, sorry. It's a little slow, just got slow. Y equals mx plus b. Think about that function. The exponent, if I don't see an exponent, it's a 1, okay? If you see a squared, obviously it's not a linear function. That would be a parabola, a quadratic function, okay? So if you see an exponent, it's not linear. How about we write that? See an exponent, that means it's non-linear. Okay, and also the variable cannot be in the denominator. Okay, I mean, think this is really our equation for lines. It can't, that variable, that x, cannot be in the denominator. So determine which of the following are linear functions. Y equals 4, there is no exponents, and the variable isn't in the denominator, so yes, it's a linear function. We know what y equals 4 is, guys. I'm going to 4 on the y-axis. It's a horizontal line. You should know that one, okay? B, y equals 2x minus 1. Guys, that's mx plus b, right? The variable is not in the denominator, and there's no exponent. So yes, that's a linear function. Let's look at C. Right away, I've got a variable in the denominator. So no, it's not a linear function. That's a rational function. Looks like this, actually. There's 2 parts to it. Definitely not linear, I'll tell you that much. Let's look at D. I've got an exponent. Right away I see an exponent, so it's not linear. That's actually a parabola. Looks like this. Definitely not linear. Y equals 4 times x minus 1. Variable isn't in the denominator. There's no exponents, so yes, it's a linear function. Guys, this is really, if you distribute that 4, slope-intercept form. We know that. Okay, look again, here's y equals mx plus b. Yes, it's a linear function. Okay, 5 is pretty sweet and short and sweet. Okay, we need to be able to compare linear and nonlinear functions by looking at a graph, table, and equation. Great job, guys. That's chapter 5.